Howdy everyone, it's Miss Kosh, and we are going to work through a few of the quadratic word problems. I might already have videos on some of these, but just in case, I'm going to try and do these three problems real fast for you. So, as always, I put my name on my paper. Okay, so it says the sum of a number and its reciprocal. So, if I had a number like 14, its reciprocal, well, this is 14 over 1, its reciprocal would therefore be 1 over 14, right? So if this is x, then if this one were x, then what we have here is this just becomes 1 over x. Hopefully that makes sense to you. Oh, go away. I don't need that anymore. Delete. Okay. So we have the sum of a number and its reciprocal, and that equals 26 over 5. Well, on this problem, we don't want x in the denominator. Actually, we don't. It would be nice to just get rid of denominators in general. So if I multiplied everybody by 5x, then I would clear out. That will help me clear out my denominators. So this gives me 5x squared plus 5 equals, the 5's will cancel, so it equals 26x. So then I need to set everything equal to 0. So 5x squared minus 26x plus 5 equals 0. I can think through this as what I have, if I look at 5 times 5 is going to give me 25. What will multiply to give me 25 and combine to give me negative 26? Well, negative 1 times a negative 25 will give me negative 26, so I could rewrite this if you'd like to do it this way. It is not the only way to do it. You do not have to do it this way, but I'm splitting my middle term, and now I'm going to factor by grouping. X comes out of the first two terms, leaving me with 5x minus 1, and then a negative 5 comes out. I keep in mind I always take out whatever that sign is, leaving me with 5x minus 1. Therefore, this is 5x minus 1 times x minus 5 equals 0. My numbers are 1/5 and positive 5, which makes sense. Those are reciprocals of each other. And if you notice, you add them together and you get 26 over 5. So the sum, find the number. It can either be 1/5 or it can be 5. Super. Okay, so the next one, I'm saying I have fencing, and I'm going to fence off 3 sides of this enclosure. So I've got a brick wall on one side, and these 3, there they go. Those 3 walls, or those 3 fences are going to add up to 40 meters. So I can call that x, I can call this x, I can call this y. Then I have my 2x plus y is equal to 40. Sorry. Which would imply that 40 is, I lied, that y is equal to 40 minus 2x. So now if we want to find the area as a function of x is going to be equal to, well, base times height, x times y, but we just said y is equal to 40 minus 2x. One thing, I just have been grading some of your tests, and you didn't use function notation very well. So be careful with that. This is saying area as a function of x is equal to, and then we only see x's over here. If I clean this up, I end up having 40x minus 2x squared. I can think about this as being a parabola that's opening down. It's going through the origin, because a of 0 is equal to 0. It's going to have, and then my other 0, so I could, there's a few things I can think about here. But if I were to rewrite this, I can factor out a 2x. I can factor out a negative 2x, leaving me with negative 20 plus x. And so my 0 here is at positive 20. And which tells me that my axis of symmetry, that my vertex is going to be up here when x is halfway from 0 to 20 is 10. This is not the only way to find this. And then when I plug that back in, well, or actually, I can say, well, therefore, that means that this x would have to equal 10, and this x would have to equal 10. We know that then the y would have to equal 20, and I can find my area by saying 10 times 20. So this area is the maximum area, or maybe I should say max area, is 200 What were my units? Meters squared. Find the dimensions of the garden. Oh, okay, so then the final question, I have to go back and look to see, did I answer the question they asked? Find the dimensions of the garden. It's a 10 by 20. So maybe I should say 10 meters by 20 meters. There we go. Let's get rid of that. Super. Okay, the next one. Caden Davis is kicking for A&M. I taught him, and I think at one point he was going to kick for A&M. I'm not sure if he is or not, but it doesn't matter. He's kicking a field goal for Texas A&M. The height of the ball in feet can be modeled by this equation, where t is the number of seconds since the ball was kicked. How high was the ball when it was kicked? So that's saying, okay, how high is it at time 0? So this is going to just be equal to 2. Notice this is gone and this is gone, and we're just left with that. How high is the maximum height the ball reaches? Well, we need to figure out its vertex. So either we've got some choices as to how we could best approach this. If we have a calculator, we can just plug that in and find its. Do I have Desmos open? No, let me go find Desmos. There it is. It was y is equal to negative 16x squared, well, t squared, plus, I think it was 60x plus 2. Let me make sure that I'm not lying to you. Yes. Okay, so when I look, and I can see here what this value will be, I can find that at 1.875, it's 58.25. I can also find what this value, what that 0 is right there. I'll try and add those two. Our notes in a second. Okay, how high is, well, okay, I don't remember. That's why I had to take the picture. Here and here, I think, is what we just did. I'm sorry, you get to watch me. You're so lucky. Okay, so how high is the maximum height the ball reaches? Well, what was its maximum? The maximum height is 58.25. Yeah, 58.25 feet. When does it reach that maximum height? Well, its time was 1.875. And I think we're talking seconds. And then when does the ball hit the ground? Well, it hits the ground at 3.783 seconds. On a problem like this, you can also use, if we had to do it by hand, we could say something like, what is the maximum height the ball reaches? Well, we can say, well, its axis of symmetry is when x is equal to negative b over 2a, which in this case would be negative 60 over negative 32, which is kind of annoying to work with. 4 goes in there 15 times 4 goes in there 8. So sure enough, I think that number matches this right here. And then we would have to take this and plug this back in right here, which would be kind of annoying. Or you could complete the square to get it to vertex form. I don't know if that's that enjoyable. And then to do something like this, when does the ball hit the ground? We can always do the quadratic formula. Say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then figure out when is when is the positive 0. So, because this graph, if you notice, well, you can't see right here. I can take you back to Desmos. If I zoom in here, you can see that it wasn't at 0, because at 0, oh, my scale has gotten ridiculous. At 0, I should be there at 2 feet high, and so this was, in theory, this would have been when it was at the ground before, but we don't care about that because we're only starting with time equals 0. And then here's the one that we care about. All right, good luck. Go practice.